Hey guys, welcome. We're doing 3.5 derivatives of trig functions. I know trig functions is everyone's favorite subject, and you will need to know some basic unit circle trig for this unit, but we're going to review that as we go throughout next week as well. So feel free to pause if you want to draw the graph or just follow along as I do this, because the graphs of the trig functions isn't of the utmost importance right now. Okay, I have the sine curve graph here. You've seen those before in college algebra. But let's look at the slopes of each point, because I want to figure out what's the derivative of sine of theta. And to do that, let's look at the derivative of each point. Remember, derivative equals slope. So at negative pi, my graph isn't great, but the slope there is 1. So negative 1. Obviously, it's decreasing. The slope at negative pi is negative 1. Okay, let's look at negative pi over 2. Ooh, that's a horizontal tangent. It's a local min. So the derivative there is 0. So negative pi over 2, I have this slope, which remember, derivative is slope, is 0. Then at 0, looks like it's headed upward, and it is, tangent line there would be positive 1 is the slope. At pi over 2, we have another horizontal tangent. That slope is 0, of course, pi over 2, 0. And then at pi, we are at negative 1 slope again. So this is the table that measures the slope at these 5 points of the sine curve. Now, if I want to know the derivative of sine, I'll just graph these points, these 5 points, and connect them and see what the derivative graph looks like. Maybe that'll give something away. I'm going to use blue since the points are in blue. At negative pi, the slope is negative 1, so the derivative would be down at negative 1, right there. At negative pi over 2, it's 0. That's the x-axis. At 0, it's 1. At pi over 2, it's 0, across the x-axis. And at pi, it's negative 1. So if I were to connect these right now, I get a curve that looks like this. Interesting. Cool, so the derivative to a sine is still a curve, but that curve should be familiar. That is the cosine curve. So you don't have to see this, you don't have to know this based on the graph, but you do have to memorize that the derivative of sine is always cosine of theta. Okay? Doing the slopes of each of the points just kind of helps reinforce that, hey, the derivative of sine is cosine. Now, what if I do it the other way around? This time I'm starting with the cosine function, right? And I found the slopes, but let's quickly go over them in green. At negative pi, what's the slope here? Well, it's a horizontal tangent. It's 0. Got it. At pi over 2, the slope is positive. That's positive 1. Got it. At 0, there's another horizontal tangent at a local max there, so it's 0. Got it. At pi over 2, what's the slope? That's negative 1. Got it. And at pi, we're at another horizontal tangent. The derivative, aka slope, is 0. Got it. I have those 5 points now, and let's look at what the derivative graph of cosine now looks like. Negative pi is 0, x-axis. Slope was 1 here, positive 1. Slope was 0 here, back on the x-axis. Slope was negative 1 here, at pi over 2, and at pi was back at 0. Let's graph this. Check it out. Okay, we see another pattern here. That's another curve. It is a trig function. It looks like it would be the sine function, but take a look. I have sine here in red. The red there doesn't exactly look like the green, but it does kind of look like a reflection of it. So the derivative of cosine isn't sine. It's negative sine of x, or theta. Let me continue using theta since they use theta. Okay? Don't worry too much about the graphs. What you need to remember is these 6 trig derivatives. There's no getting around it. You need to remember them. Whatever kind of mnemonic device you use, whatever helps you, flashcards, whatever, you need to know these. Okay? Clearly the most important ones, the most common ones being cosine and sine. The derivative of sine, we've already said, is cosine. Derivative of cosine is negative sine. The next most important one is tangent. The derivative of tangent is secant squared of x. So as you write this down, I'm going to talk about some kind of ways to remember it. Every c function, every co-function has a negative derivative, if you'll notice. Let me use the light pink here. There's a negative cosine, has a derivative of negative sine. Cotangent has a derivative of negative cosecant squared. Cosecant. All the cos have a negative, and generally, except for just the basic functions, the cos are kind of friends. The derivative of cotangent has negative, of course, cosecant squared. The negative of cosecant has negative, of course, and cosecant with cotangent. Okay? Again, no matter how many weird things I could tell you to try to remember this, memorizing is the only way to know the derivatives of trig functions without creating them on the spot using product rule and chain rule, which we're going to learn next week and next unit, respectively. The sooner you remember these, the better off you're going to be. Notice, I have another, here we go. Tangent and cotangent are the only trig functions whose derivatives are squared. The tangent has a secant squared, and the cotangent derivative is negative cosecant squared. Those are the only ones that have a function squared. Another connection that may or may not help you is that the cosecant and secant are the only function whose derivatives have two parts. Look, secant has two functions being multiplied, so does cosecant, of course with the negative, because all the cos have negatives. Okay? If you're still writing that down, feel free to pause, but we're going to jump forward. Let's now use these. Let's find some derivatives. Let's jump right in. Okay. Find the derivative of each. All right, 2 times sine. Well, 2 is just a constant. I can keep it out front. 2 times, let's see, the derivative of sine. Oh, that's his cosine. So 2 cosine of x. Done. Make sure you call it y prime or dy dx. They both mean the same thing. That was pretty simple. How about sine of x over 2? Well, I don't like that over 2. I don't like these fractions, so I'm going to rewrite it as 1/2 as the coefficient. So rewrite it as 1/2 sine of x, and then now y prime is 1/2 times derivative of sine I know is cosine of x. At least the sine derivatives I don't have to look up anymore. I know they're cosine. I'm getting there. How about this one? Ooh, got a 2-piece. Got 2 terms. Let's take the derivative of each. Y prime is, derivative of x, of course, is 1. We learned that from power rule. Plus derivative of cosine. I'll look it up. Oh, yeah, just as I thought. It's negative sine. So 1 plus negative sine of x. Of course, instead of plus and negative, you can just make that 1 minus sine of x. There's your derivative. Using trig derivatives and power rule together. That happens. Let's do this one. The derivative f prime of x. There's 2 pieces here, 2 terms. So I'm just going to take the derivative of each one. Derivative of sine, I have memorized already, is cosine of x. Plus derivative of tangent, not so positive about. Ooh, there it is. Secant squared of x. So you're seeing that the faster you memorize those things, the easier your life is about to be. Okay? Because that's it. How about this one? 3 cotangent of x. Ooh. Well, 3 is a coefficient. Put it in front. But I know that the cos all have negative. Negative 3. Let's see, cotangent, the derivative. I believe that's the one where it's squared. And I know the cos are negative and kind of friends. So I believe it's going to be negative 3 cosecant squared of x. You can put the x in parentheses if you'd like. Let's see if I was right. Yep. Derivative of cotangent is negative cosecant squared. That is your derivative. For now, you're kind of looking it up in the table, but you clearly are going to have to remember those. This one got another 2-piece. 2 sine of x plus cosine of x. Derivative is 2 cosine of x. minus sine of x, because the derivative of cosine, of course, is negative sine. That is it. That is the extent of these simple trig derivatives. Okay? But now what if they ask you to find the derivative at a given value? Well, now we got to plug it in, and we know that we're going to be using some unit circle here. I've already done the derivative. If the function y is negative sine of x, then the y prime must have been negative cosine of x. Right? Because derivative of sine of x is cosine, but there's a negative in front. But I need to find y prime of pi over 4. So what I'm going to do, is plug in, let me use a different color, negative cosine, instead of x, plug in pi over 4. And now I know that's a place on the unit circle, so I'm going to look it up. In orange, I have it up here. This is pi over 4. It's actually 45 degrees. Okay? Now pi over 4, I know is 45 degrees, so it's right in between that wedge, right in the middle, so I know that the sine and the cosine are the same. When they're the same, it's radical 2 over 2. And I know in the unit circle, it always goes cosine first is the x-coordinate, and sine is the y-coordinate. So, in this case, the cosine is what I'm looking for. There it is. The answer, because remember, when you plug in a number into the derivative, now you're actually looking for the slope. You're looking for an answer. The slope at pi over 4 is negative radical 2 over 2. That is it. You could also say y prime at pi over 4, of course, if you'd like to, equals. I plugged pi over 4 into the derivative function cosine, and then, of course, made it negative because there's a negative in front. But when you plug a radian angle measure into a trig function, you got to be prepared to know your unit circle values. Okay, but pi over 4, that's one of the basic ones. You got to know those. This is 0, or 2 pi. This is pi over 4, and this is pi over 2, which I believe we're going to use in the next problem. Okay? We'll talk about this next week. We'll have a day of trig review probably, and I'll post some stuff. But yeah, you need to know some basic trig unit circle values. Okay, let's look at 6. Okay, they defined a function y, and they want me to find the derivative at x equals pi over 2. Well, I found the derivative for you already. There it is. If you have negative 2 sine x, the derivative of negative 2 cosine of x. So I want to find y prime at pi over 2. So plug that pi over 2 in for x. That is your angle. That's what you want to find the cosine of. Cosine of pi over 2. Well, that's up here, like I showed you on the unit circle. Pi over 2 is right there. I know what that is. That's an easy coordinate. That's 0, 1. And again, I know that the first number is cosine, the second number is sine. So guess what? The cosine of pi over 2 is just 0. So in this case, I get negative 2 times 0. Great. Well, that's easy. The answer is just 0. So the derivative of this function, negative 2 sine of x, at pi over 2, it must have a horizontal tangent because the derivative equals 0 there. Okay? Make sure you try the homework. Most of them are as basic as these. The last two, you'll be plugging stuff in. I want you to try them, but we will be doing more trig practice as this week ends and next week opens up. Okay? Thank you. Good job.